because they are. So we've got special right triangles today. So we're going to talk about two specific types of triangles, 45, 45, 90s and 30, 60, 90s. Now, the question was asked, why are they special? Because they have certain properties that they hold so that we don't have to use sine, cosine, or tangent to find the missing sides. Could we? Yes, you could. But there's kind of shortcuts to these types of triangles. They hold special ratios. So if you recognize them as these two types, you can find the sides rather quickly. If you don't recognize them and end up using sine, cosine, or tangent, are you going to get the same answer? Kind of. You won't get an exact answer because you'll get a decimal for some of them, but you'll be close. But it's oftentimes easier to do this. So we've got these two triangles that we're going to talk about today, and their kind of properties that they have. So if we start out with a 45, 45, 90. So here are the ratios that a 45, 45, 90 is going to hold. Okay, so with a 45, 45, 90, that's the one we're going to start with. What that simply means is that we've got two angles that are 45 degrees, and we have one that's 90 degrees. Drawing is not to scale. From geometry, if you remember anything from geometry, one of the properties that you talked about in geometry said that if you have two angles of a triangle that are congruent to each other, their opposite sides are congruent to each other as well. So we know the two legs then have to have the same measure. So we are going to label them, for ease of purposes, we're going to label them as n. Because these are 45, those are going to be the same as each other. So if I tell you that this is 10, this length has to be 10. If I tell you this is 20, this has to be 20. If this is the square root of 3, this has to be the square root of 3. They have to have the same measure. Now, we could derive what the hypotenuse is. We could use the Pythagorean theorem and say that n squared plus n squared has to equal the hypotenuse squared, and we could solve that. We could do all of that, but for the sake of time, we're not going to do that. I'm just going to give you the ratio for the hypotenuse. The ratio for the hypotenuse in a 45, 45, 90 is n times the square root of 2. Okay, so we've got these ratios, and these ratios always hold for a 45, 45, 90, no matter how big it is or how small it is. The two legs are going to be the same. The hypotenuse is going to be the length of that leg times the square root of 2. So if this is 10, this is 10 times the square root of 2. If this is 30, this is 30 times the square root of 2. If this is the square root of 3, well, then it's the square root of 6. Okay, and we'll do some of these together, but you can kind of see how this works and why it's kind of so nice to use this instead of saying the tangent of 45 is equal to 10 over x. Well, now I got to do all of that math, and then you're just going to find out the answer is 10. Okay, so having these down is kind of a quickness thing more than anything. Okay, so let's look at a couple of examples. Actually, we're going to look at probably 3 different examples with this. First one. So we've got our 45, 45, 90. There's our 90. There's 45. There's 45. I'm going to give you the length of this side is 13. And kind of show you how I like to do these. And the way I find it, I've taught this hundreds and probably thousands of times. And I've done this different ways over the years. Used to make a table, and then if you were given this, do this, and all of this. What I found is the easiest way to do this is to do what I did kind of in this back one right here. Label the sides as n, and n times the square root of 2. So this side opposite the 45, that's going to have a length of n. This 45 is going to have a length of n, and I'm going to put that close to the 13. And then this side has to be n times the square root of 2. So I put the ratios on the triangle. And the reason I like to do that is because now the side that I know, I can just put an equal sign there. And if n is solved for already, like it is in this one, I know what the n value is. If I would have given you the hypotenuse instead, then I would have to solve for n, but it's easy to see what you have to do. So now we know the length of this side is 13. If I have to find the length of the other two sides, my n value is 13. Well, this is n here, so I know that this length has to be 13 as well. And in this one, my n value is 13, so then my hypotenuse has to be 13 times the square root of 2. And I've just found, for me, and in my mind, and the way I've taught it over the years, I've found that students find this really probably the easiest way to do it. In 45, 90s, if you're given the leg, it's not that big of a deal. It's the same times the square root of 2. Where it becomes more difficult finding that n value sometimes is if in like this second example, I give you, instead of giving you one of the legs, here's our 45, this is a 45, this is a 45, and there's my 90. If I give you the length of the hypotenuse and I say, okay, the length of the hypotenuse is now 10. How do we go about doing it? Well, again, label the sides. The two legs are going to be n and n. The hypotenuse is n times the square root of 2. So I've labeled them with the ratio that I know they have to hold. This is the side that I have. So I'm just going to go ahead and put an equal sign in between them. So now I know that n times the square root of 2 has to equal 10. And I know that my legs are n and n. So if I solve this for n, I'm going to have the length of my two legs. So off on the side, we've got n times the square root of 2 is equal to 10. I have to solve this for n. So I have to divide by the square root of 2. N times the square root of 2 divided by the square root of 2. Square root of 2 divided by the square root of 2, that cancels out. That leaves me with, that equals 1. So that leaves me with n is equal to 10 times the square root of 2. But we can't have the square root of 2 in the denominator. We've done this already this year. So we have to get rid of that square root of 2 in the denominator. The way we do that is we multiply both the numerator and the denominator by the square root of 2. When we do that, it's 10 times the square root of 2. We'll put over the square root of 4 for now. We can't multiply 10 times 2 because 10's on the outside, 2's on the inside. And then radical 2 times radical 2 is radical 4. But we know what radical 4 is. That's 10 times the square root of 2 over the square root of 4 is just 2. And now because the 10 and the 2 are on the outside, the result of this then is 5. It's not me. The result of that is just 5 times the square root of 2. So now I know what my n is equal to. So if I go back to my drawing then, my two missing sides are here and here, are n and n. So now I know that the length of this side has to be 5 times the square root of 2, and the length of this side has to be 5 times the square root of 2. I find that the easiest way to do these. Is there something that happens here? Yes. I mean, you can think about it in your head, and if you can see it, maybe you can see it. But I find that the easiest way to do it because it works in all situations. Okay, honestly, it's half times the square root of 2, going from the hypotenuse to here. It's half times the square root of 2. That's what it is, every single time. It's half of that times the square root of 2 going from the hypotenuse to the leg. When you're given a nice number, that's easy to think about. If I gave you 16, for the hypotenuse. Half of 16 is 8. It's 8 times the square root of 2. Fast to do. But what happens if I don't give you that? Let's say that we have one where I give you it as a radical. Okay, so here's our 45, 45, 90. This is 45, this is 45. There's my 90. But now I tell you that this is radical 6. Well, half of radical 6 times the square root of 2, huh? I don't know. I don't even know what that is. But if I can label the sides, my legs are n and n. My hypotenuse is n times the square root of 2. Now I can set this equal. Go off to the side here a little bit. The square root of 6 equals n times the square root of 2. Solve this for n, divide by the square root of 2. What's 6 divided by 2? 3. So that's the square root of 3 is equal to n. So my n value is the square root of 3. Much easier to do that than go 1/2 times the square root of 2. Eek. Okay, so setting it up like that, I think is the easiest way to do it. That makes this one the square root of 3, and it makes this one the square root of 3 as well. Okay. So that's 45, 45, 90s and the special properties of 45, 45, 90s. We'll come back here at the end and we'll do one more example that I'll have you do by yourself with a 45, 45, 90. When you get on a roll with these and they're all the same, it's not too bad. What happens when you start mixing them together? So let's talk about then the 30, 60, 90 degree triangle. With a 30, 60, 90 degree triangle, you are going to have an angle that's 30, an angle that's 60, and an angle that's 90. That's so close to looking right. There's my 90. Let's say that this is 30, and this one is 60. Draw yours a lot closer to a 90 degree angle than I just did, but whatever. For a 30, 60, 90, our ratios for a 30, 60, 90. I call this the side opposite the 30 degree. I call that the short leg. It's the shortest of them. It's the shortest of the legs. Again, the legs make up the right angle. The shorter of the two legs is the side opposite the 30 degree angle. That is going to be n. Just like opposite the 45, we said that's n, and a 30, 60, 90, we'll say that's n. The hypotenuse, which is this side right here, the hypotenuse is going to be 2 times n. The hypotenuse is 2n. I know 60 is twice 30, then shouldn't that be twice? No, it's not. It's a Pythagorean theorem thing. Okay. The long leg, which is the side opposite the 60 degree angle, which is the longer of the two legs, that is going to be n times the square root of 3. So we've got n for our short leg, 2n for our hypotenuse, and n times the square root of 3 for the long leg. Short leg is opposite the 30 degree. Long leg is opposite the 60 degree. And the hypotenuse is opposite the 90, which is the hypotenuse. I do this the same exact way. You're going to be given one of them. You have to find the other ones. Set the ratios up every single time. Put the equal sign in there. Figure out what your n value is. Okay? Again, we say n to 2n to n times the square root of 3. And the square root of 3 is less than. Okay? So let's look at some of these. Look at a couple examples, 2 or 3 examples of this. Okay, so here's our first one. Draw. It's not drawing. So here's our triangle. There's our 90. I'm going to make this our 30 this time, and I'm going to make this our 60. And I'm going to tell you that this side is 14. So I'm going to label sides first. The side opposite the 30 is n. So here's my 30 degree angle. Side opposite is n. There's my hypotenuse. That means that has to be 2n. The side opposite the 60 is n times the square root of 3. Put an equal sign between the side I have and the ratio that I know it has to be. Oops, look at that. I already know what n is. Don't have to solve anything. We know it's 14. I just made that up. They have to be given one of the sides. That's the side I gave you. So when we find the hypotenuse is just 2 times n. Well, my n value is 14. So 2 times 14 is 28. So the length of my hypotenuse is 28. The leg is n times the square root of 3. My n is 14. So that makes this 14 times the square root of 3. And those are your answers, and you're done. There's nothing left to do with it. So if they give us this one, pretty easy, right? What other one's pretty easy to do? The short, if I give you the long leg or the hypotenuse, which one's still pretty easy? Hypotenuse ain't so bad, right? So let's do one where I give you the hypotenuse. I'm not going to go through that pain of drawing that thing in there this time. So here's my triangle. Here's my 30 degree. Here's my 60 degree. This time I'm going to tell you the hypotenuse is 18. Well, for my ratios, here's my 30 degree angle. The side opposite the 30 degree is n. My hypotenuse is 2n. And my long leg is n times the square root of 3. Well, I have a 2n where my 18 is, so I'm just going to set them equal to each other. So 2n equals 18. What's n equal to? Two n equals 18. Divide both sides by 2. N equals 9. So this side is 9. This side is 18. That side is 9. My n value is 9. So that's going to make my long leg 9 times the square root of 3. And there are your 3 sides. Again, it all becomes about finding n. Do that on the side. You have to. So just like the last one, of course, then where it becomes its most difficult is if you're given the long leg. So here's my 60, there's my 30, there's my 90. Drawing is not to scale. Let's say that this one is 18. So I look at it, and again, I'm going to label my sides. I find my 30 degree angle. I draw an arrow to the opposite side. That's going to be my n. My hypotenuse is going to be my 2n. The long leg is going to be my n times the square root of 3. Always do this first until you get good at it. My number is 18, so I'm going to set those two things equal to each other. So I've got n times the square root of 3 equals 18. So off on the side, n times the square root of 3 equals 18. I have to solve for n. So divide by the square root of 3, just like we did when we divided by the square root of 2, but now it's the square root of 3. Square root of 3 divided by the square root of 3 is 1, so that just leaves me with n equals 18 divided by the square root of 3. Multiply by the square root of 3 over the square root of 3. Can't have a radical in the denominator. And because this is underneath, you can't simplify that way. So that gives me 18 radical 3 over 18 radical 3 over radical 9. 3 times 3 is 9. So an extra step, but so that's 18 radical 3 over 3. The 18 and the 3 are on the outside, so 18 divided by 3 is 6. So my n value is equal to 6 radical 3. So now you go back over to your drawing. This one is n, so this has to be 6 radical 3. That's the answer. For the hypotenuse, it's 2 times n, so 2 times 6 radical 3, which is 12 radical 3. And there's your solution. And you're done. Okay. And again, it all becomes about, one, being able to do this algebraically. Okay, we've done this before. Is there a shortcut for this one? Yeah. It's a third of it times the square root of 3. If you've got a number that's easily divisible by 3, it's not so bad going from the long leg to the short leg. It's 1/3 times the square root of 3. And then that's 2/3 times the square root of 3. Or whatever. So those are your 45, 45, 90s and your 30, 60, 90s. As you kind of go through them, you get more and more used to them. And like I said kind of at the beginning, if you kind of just keep going through, it becomes pattern. But let's kind of throw 2 questions in here now where one of them's a 45, 45, 90 and one's a 30, 60, 90. And I want you to go ahead and see if you can find the missing sides. So the first one, we're going to do a 45, 45, 90. And I'm going to tell you the length of this side of the hypotenuse is 24. I want you to find the value of x and the value of y. Now don't let the value of x and the value of y mess you up. We're not doing anything different than you did before. Just kind of push those x's and y's out of your mind and make them the sides that they need to be, n's or whatever they need to be. See if you can find those missing sides. Go. If you remember the shortcut, you've probably done already. Sounds like we're done. So label the sides. N and n. 24 is n times the square root of 2. Set those two things equal to each other. So we've got 24 equals n times the square root of 2. Divide by the square root of 2. That gives us 24 times the square root of 2 equals n. So multiply by the square root of 2 over the square root of 2. So that's 24 times the square root of 2 over the square root of 4, which is just 2. 24 divided by 2 is 12. So your y value is 12 radical 2. And your x value is 12 radical 2. And there are your solutions. And you're done. Half of it times the square root of 2. If you can remember the shortcut. It's assuming you can remember the shortcut. Last one. I'll have you do a 30, 60, 90, and as you're doing this, I'll hand out your worksheet. There's your 30. This is really not even close to being drawn to scale. There's your 30, 60, 90. I'm going to give you the hypotenuse in this one. We did that already. Let's do the hypotenuse of 14. Find the length of the long leg and the short leg. Going through it, grades are up to date. I put in any missing work that has been turned in. I turned that in. I put that in the grade book this morning. So my grade book, unless you turned something in after 8:30 this morning, grade book is up to date for everybody, including you. Shep. I put yours in there too. Beep, beep, beep. She got a lot of dings this morning. All right, so let's label the sides. Are we good? Need a couple more seconds? So the short leg, opposite the 30. I know it looks like the longer one here, but whatever. That's n. The hypotenuse is 2n, and n times the square root of 3. So we have 14 equals 2n, so n equals 7. So that makes my y value 7, and my x value 7 times the square root of 3. And that's 45, 45, 90s, and 30, 60, 90s. Okay?
We need an extra.
Did I give you one too few? So that's what you're going to work on today. The first part of the assignment today is working on special right triangles. Please use these ratios. Do not use sine, cosine, and tangent to do these. Use these ratios to help you find them for the first 10. And then the rest of them are review from the week. On Monday when you come in, Monday is going to be kind of an accumulation of everything we've done day. So it's going to be kind of a review day on Monday. Does that mean we're having a quiz on Tuesday? No, we're not. You're not going to have a quiz for about another week and a half. So we're going to do law of sines and law of cosines all of next week. And then we're looking at a quiz, whatever that Tuesday is, like the 4th or 5th is when your quiz is going to be.